Hi guys, in the previous video we have seen how to calculate the slope of a straight line, but as I have already told you the same concept can be applied to calculate the slope of any simple curve. Now the point is, I have already told you slope means tan theta, which is tangent. Now, if I take a simple point over here, the tangent which can be drawn to this curve would be this, right? Now, if I take one more point which is this, the tangent which could be drawn to this point would be this. Now, if you could notice the line over here and the line over here, obviously both the lines have different slopes, different inclinations. That does mean that any curve has infinite number of tangents which can be drawn. That does mean the slope, the tangent, the tan theta changes at every single point on the curve. But how to calculate that slope? I would say draw the tangent. But is it practically possible to draw every single curve and to draw every single tangent to get every single slope value? No, it's not possible. So we take the help of mathematics to ease that process. Now let us try and treat this curve just like a straight line. How do we find the slope of a straight line? We just take two different points and take their differences, y2 minus y1 and x2 minus x1. Let us try the same thing over here. Let me take this point be x. But we have already studied the chapter of functions in which y is a dependent variable which depends on x. So y can be written as fx. This particular point is x and this particular point is y, which is nothing but fx. Let me take another point which is this, but this point has some increment in x. Let this point be this. Now this will obviously be greater than this point x. Let me say that amount is h. So this coordinates will become x plus h, comma. Obviously y depends on x. So a small change in x, that is h, will also cause an effect in the value of y, which is f of x plus h. I have 2 points, x comma fx and x plus h comma fx plus h. Now if I calculate the slope by using these 2 points, I would say y2 minus y1 upon x2 minus x1. But you know what kind of slope am I going to get? I am going to get this slope. Now the idea might be very clear in your mind that the slope is in fact changing at every single point on the curve between these 2 points. But if I calculate simply y2 minus y1 and x2 minus x1, I would get the slope of this straight line, which is not what I desire. How to do that? Imagine that this h value is very small. What would happen then? Then this particular point will be so close to this particular point that I could not differentiate between the 2 points. Those 2 points could be so close. For example, this, I do this curve, I am magnifying this. This is your first point, x comma fx, and the other point could be treated as this, x plus h comma fx plus h. Now you can imagine if I reduce the value of h by even smaller amounts, what is going to happen? These 2 points are going to become very close to each other. And what would happen then? Can you differentiate between the two? Obviously you can. But if I want to draw the tangent, what I would do? This point or this point? But they are very close. The tangent could be drawn like this. And yes, I can draw only a single tangent at this particular point. Why could I do this? Because the increment h, I made it very small. Now let us assume that this increment h is very small and these 2 points are very close to each other, so that we can treat them as a single point. But in reality, they are 2 different points. Let us try to analyze the slope. Slope is equal to y2 minus y1 upon x2 minus x1. What is y2? fx plus h, fx plus h. What is y1? fx minus fx. What is x2? x plus h. What is x1? Only x. Now you can notice that this x is going to get cancelled, and what you get is fx plus h minus fx upon h. Right? Now, this h is very small. Imagine these 2 points have to be very close to each other so that they can be treated as single points. What would that case be? H has to be 0. Now if h is 0, these 2 points will be the same. And I can draw a single tangent. But the problem would be the denominator. Can I divide by 0? No, definitely I cannot. In the earlier standards, we have seen or studied that we cannot divide by 0. It means h can be very small but cannot be 0. Now go back to your chapter called as limits, in which we used to say limit h tends to 0. Now you might understand why we used to call h tends to 0. It is very small, it is tending to 0, but it is not 0. Why? Because I do not want the denominator to be 0, and that is nothing but what? y2 minus y1 is the difference in y. I may write down dy, and x2 minus x1 is the difference in x coordinate. I may write dx. Yes, you know what this is. This is called as derivatives, which you have already learned, dy by dx. And this particular thing over here, you already know this. This is called as first principle of derivatives. And this particular thing you have already studied so many times in your 10th standard, which is the general formula of slope. I hope now you understand the actual meaning of derivatives. In the upcoming videos, we are going to utilize this and calculate derivatives of various functions. Thank you.